Hello, this is Mr. Collier, and today we're doing Indices Laws practice. Indices is a very British term, also called exponents. Okay, so basic exponent laws. Okay, when we're multiplying, we add the exponents, so you simply add the exponents. In this case, if you've got the same base, same thing here. Now we got some numbers, 2 and 7. You can multiply those together to give you 14, and for the a's, you add the exponents and you get 8 to the power of 13. Okay, it's as simple as that. Dividing is subtracting the exponents. 8 minus 4 gives you 4. Now the next one's a bit ambiguous. Technically, well, people don't use the divide sign in advanced mathematics. We should probably write it like this, and then it's clearer. All right? Okay, then for numbers, just do some regular dividing here. That's 4. And for x, we're going to have x to the power of 1, because it's 3 minus 2. Y to the power of 4, z to the power of 3. Just subtract the exponents when you're dividing. Now, an exponent of an exponent, that means you're doing, if this is cubed, then you're going to have 2r squared times 2r squared times 2r squared. So the 2 is times itself 3 times. And the r as well, so you're going to get 2 cubed r to the power of 6, or 8 r to the power of 6. 3 to the power of 5 is quite large, so I'm just going to leave it as 3 to the power of 5. And here you do exponents before multiplying, so you're going to have p times p to the power of 12, and overall you get p to the power of 13. Now 8 over 6, that doesn't divide, but you can simplify it to 4/3. And then you've got s to the power of 2, t to the power of 1. Subtract the exponents, right? Here you can multiply the numerator first and then simplify, or you can simplify right away, kind of up to you. I'm going to simplify the numerator first. Okay, so the 10/3 doesn't really simplify, and you get x squared, y squared. Alright, so you can do similar things. Let's look at, let's see, there's a more interesting one here. This one's somewhat interesting. So we've got an exponent of an exponent, you multiply, so you just do 2 times half, so you just get x, and 3 times 1/3. It's just x to the power of 1 again, so the whole thing just simplifies to 1, right? It's a common instruction, right? As with only positive powers, this is 1 over c to the power of 5. The only negative exponent here is the negative 4, so 23b cubed is still in the numerator, and the denominator is 8 to the power of 4. Here you can cube the 7. Okay, 7 cubed is 7 times 49. Is that 343? I think so. And you're going to have x to the power of 3. Now this is going to be, well, you basically add the exponents on this one, and you get y to the power of 0, which is just 1, right? Now let's check this one out. You got 2, let's write it like this, 2 over 3, x cubed, x to the power of 5. This is y to the power of negative 2, y to the power of negative 5. Now there's a couple ways you can do this. You can subtract, get 2/3 x to the power of negative 2, y to the power, now that you're subtracting, so be careful there. Negative 2 minus negative 5 is positive 3, so it's like 2y cubed over 3x squared. Or you can, if you've got a negative, like y to the power of negative 5, you can kind of like flip this up here and flip this one down here. You can rewrite it that way. And you've got like 2/3 x cubed, y to the power of 5. Let me write it like that, x to the power of 5, y to the power of 2. Now when you've got x cubed and x to the power of 5 down here, you can cancel it through the 3 of them here and 3 of them there, and then you just get 2y to the power of 3 over 3 x squared, same thing, right? So there's a couple ways to go about that. So when you do this one, and I see this c to the power negative 4, you can just bring that up in the numerator as c to the power positive 4, so you get c to the power 6 there. 12 divided by 3 is 4. Now you got a to the power 6 down in the denominator and a to the power 4 in the numerator, so that becomes a squared denominator. You can bring this down, get a b to the power 6, and this goes up c to the power 6. Here I'm going to maybe simplify the numerator first. So you're going to have 10 x to the power of negative 3, y to the power of 10 over 5x, y to the negative 2. 10 divided by 5 is 2, of course. Now this x to the power of negative 3 can come down here. You're going to get an x to the power of 4 in the denominator. And this comes up and you get y to the power of 12. Okay, and we can also write exponents as surds. To the power of 1/4 is the same thing as the 4th root of b. And here you have a fraction, and the denominator is the surd part, so it's the 6th root of c to the power of 5. Here you can multiply it out first. Maybe that's the best way to do it. W to the power 3 over 2, which means the square root of w cubed. Here you get an exponent of an exponent, so you multiply them. A to the power of 2/15, which means 15th root a squared. Okay, right with fractional indices or fractional exponents. So cube root is to the power of 1/3, and this is 7th root, so this becomes 3/7. For something like this, you probably want to do it in a couple steps. This is cube root, so this is like y to the power of 2/3 to the power of 4, and when you have an exponent of an exponent, you multiply the exponents. So it's y to the power of 8/3. Similarly to this one, notice the 2 is inside the brackets, so you can have 2 to the power of 8. Maybe we can work that out. And this is x to the power of 5/4 to the power of 8. 2 to the power of 8 is not too bad. You could probably do that. It's like 2, 4, 8, 16, 32, 64, 128, 256. And for here, you get an exponent of an exponent, so you can multiply them, and you get x to the power of 10. Okay, you got stuff in the brackets to an exponent. Then make sure you do everything in the brackets to that exponent. So you got to do 3 cubed, which is 27, x cubed over y cubed. Here it's much easier to simplify the x's first. This is like 3 over x, y to the power of 6 to the power of 7. 3 to the power of 7 over x to the power of 7, y to the power of 42. And for questions like this, it's much easier to simplify everything in the brackets first. That's usually the best thing to do. Okay, this is like, you can simplify by dividing by 4, you get negative 3 over 2. Now the a's, you're going to have a to the power of 11 divided by a is a to the power of 10. For the b's, you're going to have 1b. Actually, the b's totally cancel. You get b cubed in the numerator, b cubed in the denominator, so they're canceled. C's, you got c squared over c, so you get 1c here. And we're squaring it, so it becomes positive 9 over 4, a to the power of 20c squared. Similarly, for this one, it's easier to simplify what's in the brackets first. 12 over 16, we can divide by 4 as 3/4. For the x's, we get x squared. For y's, they totally cancel, and the z can come down here and have z cubed. Okay, now the negative 3 exponent, the negative means you flip the fraction, so it's like 4z cubed over 3x squared to the power of 3, and 4 cubed is 64. The denominator is 27 x to the power 6. Okay, evaluate that without a calculator. You can do this with numbers as well. They all got the same base, so you can simply add these exponents together. You get 10 minus 5 is 2 to the power of 5. which you can work out, right? That's 2, 4, 8, 16, 32. Now, it looks like they're all different exponents, but you can rewrite them. Actually, this is square root, right? To the power of half. 2 cubed is 8, and 32 to the power of 0 is 1, so it's just 4 times 8, 32. So remember what the negative exponent means on the next one? That means you flip the fraction. Right now the fraction is 27 over 1, so it's going to be 1 over 27. 3 on the bottom means cube root, and the 2 on the top means squared, so this is like 1 over 3 squared, which is 1/9. There's another way to do that one. You could have recognized 27 as 3 cubed, so 3 cubed to the power of negative 2/3, and then you multiply the exponents, so it's like 3 to the power of negative 2, which equals 1/9. Yeah, here again, you can multiply the exponents together. You get 12, 4 times half is 2, so that's 144. And next, you get to the power of a half. So you can multiply the exponents and get 2 to the power of 4 over 3 squared, which is 16 over 9. Now remember, the negative means you flip it, so it's like 4/3 to the power of 3, which is 64 over 27, right?